Hi. Alright, this is also one of the examples of rate of change which is under the application of differentiation. Okay, if you look at this formula is very famous, right? For those who study physics, they know this formula, right? It's the thin length formula, right? It's a thin length formula. So 1 over u plus 1 over v is equal to 1 over f. For students that know physics, this is very important and this is related to maths. So I'm going to teach you how to using the rate of change, the concept of rate of change apply to these cases here. So as you see that, okay, mathematically, we just see this as mathematically, you know that two variables u and v are related by this equation, right? So where f is a constant, right? F is a constant. Of course, f is a constant. Do you know why? Because it's from a fixed lens. It's a lens, right? If you use a convex lens, all right? So you know that lens, they have a circle focal length, right? So this is a constant. Remember, this is a constant. Every lens, a lens only have one focus, right? So the focal length will be the same, right? So now means that given that u and v are changed, remember u and v are changed, but f is not changed. So find an equation that relate du, dt, dv dt, u and v. So they want you to relate this to the rate of change, right? So as you remember, this is a constant. This is a constant. Remember that. So usually I was asking students, if you want to find du dt or dv dt, you're going to relate, right? You're going to relate this du dt is actually du dv multiplied with dv dt. So this is a fundamental, very fundamental concept of rate of change. So, alright, how to apply to this thin length formula here? So now you have du dt equals to du dv multiplied with dv dt. As you cancel out the dv, you can see du dt, right? So now you focus on this, how to get this, right? So then I'm going to rearrange this. As this is a constant, this is just a constant, right? So I will let this thing to be a constant, means that 1 over u plus with 1 over v equals to c. It's a constant. If you differentiate, you're getting 0. Okay, now you have 1 over u. So I can differentiate it implicitly. Alright, I can use the concept of implicit differentiation, as you already learned implicit differentiation, right? So I can use the concept of implicit differentiation. So, and you have u to the power of -1 plus with v to the power of -1 equals to c, right? So now I'm going to differentiate u with respect to v. Differentiate u with respect to v. So now it's just like this is your y and this is your x. Alright, so differentiate, you have negative u, -2. Just like x -1 plus y -1. Try to imagine x to the power of -1 plus y to the power of -1. So differentiate this basic rule, negative u power of -2. But for this, you have negative v, -2, right? But you have to add on with du dv, right? So you're supposed to, no, alright? You're supposed to differentiate this with respect to v, right? So this is your y, this is your y. And this is your x. As you differentiate u with respect to v, means you find du dv. Du dv is just like dy dx, okay? Dy dx means u is your y now. So differentiate u, you have negative u to the power of -2, right? Negative u to the power of -2, and you add a du dv here, plus with, differentiate this is just like x, right? Just like x, alright? So differentiate v, you are getting negative v to the power of -2. Negative, as you differentiate a constant, or you don't want to replace this with c, is okay if you don't want, right? It's okay because you differentiate this is a constant, right? You differentiate a constant, you are getting 0. That is the most important thing you must know. As you differentiate constant, this must be 0. So then you have -1 over u to the power of 2 du dv, negative with 1 over v to the power of 2 equals to 0. So now -1 over u to the power of 2 du dv is the same as positive 1 over v square, right? Positive 1 over v square. And negative u square, you are getting du dv. Lastly, you are getting du dv to be negative u square over v square. This is a very important thing that you must get it. So negative u square over v square. So then, okay, let's look back the question, right? Let's look back the question. The question wants you to find the relationship between du dt, dv dt, u and v. So very simple. Du dt is the same as du dv, right? Du dv, which is negative u square over v square, right? This is negative u square over v square. Then multiply with dv dt. If I write it nicely, du dt is the same as negative u over v square dv dt. Then I have generate the formula that relate the rate of change of the u from the v, right? So du dt is negative u over v square dv dt. As the question mentioned, you must have du dt, dv dt, and u and v. So this is a relationship here. So the question is not end yet, as they want you to as they tell you that the u is decreasing. The u is decreasing means that the du dt is a negative number. It's decreasing. It's decreasing at the rate of 2 centimeters per second. So calculate the rate of increase. Oh, when u decrease, then they want you to count the rate of increase of v. So I don't know what is it, but when the time u is 50 cm and the focal length will be 10 cm. So given u and v, right? This is all the information given. So you want to find dv dt, and you given u and f. But you know that you want to find dv dt, you need the value of u, the value of du dt, negative 2, you have everything you have, but except v, right? It's not given v. But remember, it's just like a problem. In the previous example, I explained about the concept of ladder leaning against the wall. It's just like the same as this. They given you the variable here so that you can use this number, substitute back into the original equation here so that you get the value of v first. All right. So now I'm going to get the value of v by this thin length formula here. So which is 1 over u 50 plus with 1 over v equals to 1 over f, right? Your f is 1 over 10. So 1 over v will be 1 over 10 minus 1 over 50. So you are getting 1 over 10 minus with 1 over 50, which will give you 2 over 25. 2 over 25. So v will be 25 v over 1, and then become 25 over 2. So v, when the time u is 50, f is 10, so your value of v will be 12.5. Okay, 12.5 cm. Now you have v, you have u. Don't need the f, right? You just use the f to finding the v. So now you can find the rate. You can find the dv dt. So the question requires to find the rate of increase of v, dv dt here. So du dt is negative 2. Remember, it's negative 2. Negative 2. So equals to negative u. U is 50. U is 50, right? U is 50. V is 12.5. 12.5. Okay, then you want to find dv dt, right? You want to find dv dt. So by calculator, you know that dv dt is the same as negative, negative, positive, right? So it's 2 times with 12 0.5 divided by 50 square. So it's 2, negative, negative, positive 2, and this one go there, become invert, so become 12.5 over 50 square. So you have 2 times with 12.5 over with 50 square, right? Which give you 1 over 8. 1 over 8 is 0.125. 0.125 centimeter per second, right? So this is the rate of increase. So as the du dt, as the rate of decrease of u is -2, the rate of increase of v will be 0.125 centimeter per second. Alright, so this is how I solve this type of problem that relate to Thin's length formula. So if you have encounter this type of problem, then you try to think about what am I talking about here, right? So I think that's all for this video. See you.